Well, hello there, hello there. What is up? Let me see if I can get my audio levels to be somewhat nice. Just like last time, I'm sort of experimenting with different positions for the microphone. So let me know if you can't hear me or if I'm way too loud. Anyway, welcome everyone to this almost completely unannounced stream. Today we're going to work a little bit on the NavMeshes. Alright, I can actually draw them from here. So last time we did a little bit of work on the ability for our friends in the game to actually drive to you. Voice is fine. Thank you, Nick, for the report there. Yeah, let's look at the problem that I'm attempting to solve today. So let's go into the game here. Just silence it for myself here. So basically we have a NavMesh. We will probably have several of them actually. We can turn on the NavMesh rendering here to see what's going on. NavMesh rendering is actually kind of heavy because it's just using the debug drawing functionality for that, which is not really optimized for doing this sort of rendering almost every single face on the level like this. So it's a bit choppy, as you can see. If we turn off the NavMesh rendering, there we go. We get back to 60, or at least it's almost locked 60. This is of course a development build, so it's a bit heavier than the final game. But anyway, the thing is, we have these places in the level where we can modify essentially whether or not something should be able to pass through. We have this gate here. And so if I run the script, this development script which opens the main gate, we can see that those meshes are marked when baking the NavMesh as blocking the NavMesh, and that means that you can't really, even if the physics bodies are no longer there, now we can drive through this. It's opening here, as we've done many times. The NavMesh is cut off here, and you can see, of course, that the vehicle is cutting off a piece of the NavMesh as well. And the way the vehicle is doing that is actually using the dynamic NavMesh obstacle system, which we talked a little bit previously about. Now, my plan for this, or the idea that I had, was basically, what if we, in cases like this, what if we mark those gate meshes? I'll close the gate again here. What if we mark the gate meshes as simply not blocking the NavMesh? And then we had a new system here, which would be like a scriptable NavMesh obstacle. So just like how this car cuts out a piece of the NavMesh as we're driving through it. If we drive fast enough, it actually doesn't, because it kind of considers it to be unnecessary to do that. You see, that just goes away. But if we're driving slowly enough, it will cut out pieces of it. So we could basically just have essentially a scripted obstacle that covers this part of the gate and another one that covers this part of the gate. And just like how we script the opening of the gate, we can sort of script the removal of that obstacle. That should allow us to basically dynamically change the nav mesh in a way that we currently can't do. Should actually be somewhat easy to do, I think. There's another new thing that I've added since last time. We have this mother vehicle over here. We can now select this debug AI brain, and this just tells us a bunch of things about what is going on. We can do the same thing for this one, but this doesn't have AI active currently. Because the AI driving component for this scout is set to false. For the mother it's actually active, but it's just quite simply stopped currently, standing over there. But if we order it, or ask it rather, to come to us using the new radio system that we added some time ago. We can do a move here. We don't actually get any sort of nice radio affirmation or something yet, which is something that I want to add one of the characters to say something like "on our way" or whatever. Or if they can't actually find a path to you, then they should just go like, "Nah, I can't do that. I can't find my way over there." But here we can see interesting things like the acceleration. Those are sort of normalized values. So acceleration is set to 1, brake is -0. Steering should go to like negative now that it comes to this corner. And we can see that now it's -1, so it's like essentially like cornering fully to the left. And now it arrived at its destination. So this should allow us to just track the state of the AI agents much better than we were able to currently or previously do. Like if you saw a previous stream of mine that I had, there was like a vehicle that was basically like standing up on this somewhere around here. I have my mouse movement on. Somewhere around here, and I was asking it to drive down here, and it just like it wouldn't do anything, and that was kind of annoying because I wasn't really sure what was going on. My theory is that it was the NavMesh query somehow failed, but it was kind of tricky to see that. Anyway, now if we now we can actually just ask it to move there again. We can see that okay, we have the final state machine follow drive line active, and it should pretty soon actually come to a stop. Right, so now it's stopped. We can see some other arrival distance epsilon. It's basically like how close to the target position does it need to be to actually consider like at destination. But that's fine. Now if we open this gate again through this development command here, open the main gate, and then I drive here. Now if I ask it to come here, I don't think it will actually be able to do that. So let's see, campaign mother, move here, and we can see active true, reversing enable false, initial path query pending is set to true. Right, so it's trying to find a path. Interestingly, the path finding hasn't failed, so I don't know exactly what's going on, but it has like 0 vertices, which basically means that it doesn't really have a path to follow. I was actually expecting has failed to be set to true, but it doesn't seem to be. I mean, the debugger is already kind of paying off here. If we ask it to move here, we should get, yeah, now we have like 7 vertices. And the vertex count goes down as it is actually nearing the destination that we wanted it to go. Oh, it probably won't be able to take that curve. Right, okay, actually, yeah, it kind of arrived. Because there's some other interesting output here. Movement, move to action, movement, finish. And the result was success. So, Anyway, my point of all of this is that this guy currently cannot find his or her way, their way over here. I can go move. We should see. All right, here we actually maybe see it a little better. It's interesting that has failed is false. It probably actually kind of resets the drive line after it decides that it can't find its way over there. But here we can see that NavMesh query failed, could not find path, and then the move to action movement finished, and the result is path not found. Right. So, is a problem. And of course, we can sort of move these obstacles around the NavMesh, as we can see with this car. It sort of moves in steps, and the reason it moves in steps is that it sort of re-tessellates one of these tiles on the NavMesh. So it's not something that you typically want to do like super often. Now for this gate, even though these gates are moving, these gate pieces, close main gate, even though they're kind of moving like this, I don't actually think we need to sort of move the obstacle along with the gate like that. Instead, I think we can just quite simply add or remove the obstacle there, as the gate is kind of like at the halfway point or something like that. So it would be closed, and like now it would be open, something like that. That should probably be fine. I think. So let's get cracking on this thing. So I want a new component. I want a new object type essentially. And the new object type should be something like scripted NavMesh obstacle. Oh, did I? Yeah, I messed around with the console there. So we have some other things called scripted something, scripted timeline component. And this, of course, is like one of these. Where do we find it? Mission elevator. This is a timeline. This is a scripted timeline. Scripted timeline component. And basically, yeah, we can call like things like self-play, finalize setup. We add all of the events there. This has like pause and stop methods and things like that as well. So we'll probably just have, you know, like methods for like adding to the NavMesh or removing from the NavMesh. And currently, my obstacle system is a little basic, shall we say, in that I only support cylinders currently. So if we go to NavMesh runtime, let's see. We have NavMesh obstacle ID. We have an invalid constant. NavMesh obstacle type. So we have small, large, or fast moving. So typically the vehicles are fast moving, and then I would guess like those gates would probably be like of type large. A large object that always needs to be avoided. Then we have small ones that are like barrels and things like that. If they're in the way and a vehicle can drive around them, it should. But if it can't find a path around them, then it probably can't just drive through them, essentially. And then we have three methods. So you add an obstacle. NavMesh ID essentially specifies like which NavMesh we have. Currently we have just one, but I think the mother vehicle is large enough that it will need its own NavMesh eventually. So I'll actually shut that down already. Hey Łukasz, yes, I just went live. I was actually planning to stream today, but I figured this is a pretty nice little exercise for me to do these scripted NavMesh obstacles. Let's just do them on stream. Yes, anyway, three obstacles. You give three functions for managing the obstacles. NavMesh ID, which NavMesh are you talking about? This is then the radius. So these are all circular or cylinders currently. Then with the type that we specified earlier, where it goes, and its velocity. So this will be 0 then. And you get back an ID. And then you can update the position of that. So we could, in theory, at least update the position. I wonder how is that actually. I think that's with like a transform animation that we actually move them, right? Let's have a look. Let's have a look. Right, so it's a lift station and it's main gate. So sliding door, this guy is basically this, and it's just a mesh, and it has a transform animation, right? So this is its own object type, refinery sliding door. Okay, cool. What if we like what I'm trying to figure out here is that do we actually move the object, or do we just slide its mesh and collider around? So we have these guys. We can enable the AABBs. We can enable the physics shapes as well, and then open main gate. Yes, we actually we do move the objects around, it would seem. So in theory, we could make this new scriptable object thingy slide along as well. But we'll see. We'll see when we come to that. Let's just add a new component and get going. So new file, scripted NavMesh obstacle component. Right. Let's take something as like a good component to start copy pasting from. This is exposed properties. That is what we want actually. And this is scripted as well. So this will be nice. Yeah, let's get this. Take that one, copy it here, and I want to call it scripted NavMesh obstacle component. Registration name is means.scripted NavMesh obstacle component. Yeah, we have a bunch of things here that we don't need. We don't need any propagated values. This will run completely on the server, so that's fine. We have one exposed property, which is the script code. If you want to script something that you need, then you need to have this enabled or exposed to the editor there. I think we can get rid of all of that probably, and all of these. It's from a minigame thingy that I created earlier on an earlier video. Let's see, an object created, we don't need any propagated values, but we might actually want to have let's add that back in. I don't think we need a tick function, but if we want to move it, then we'll want to move it in the tick. So we can keep that. We can comment it out if we want to have it. Then we can easily get it back. Then with the scripting API, and this is kind of what we will want to actually expose to the scripts. Yeah, we can just get rid of these guys. So we'll probably want to have a function called something like add to NavMesh. And since we're working with AngelScript, and this is Zig, AngelScript is kind of meant to or designed for interop with C++ more than Zig. So I have to jump through some hoops to actually get this to play nice with Zig. And so typically what I do is I have like a wrapper function here called underscore add to NavMesh, and then maybe we'll have a public pubfn called just add to NavMesh, and this can use just the normal sort of idiomatic way of referring to itself here with a self pointer. This actually needs an int pointer, and we need to actually cast it like this, and then we can call, add to NavMesh like this. And these ones we can then actually bind to the script. Something like this, and then same thing here. Like that. Right. So these two we want to expose. That's kind of easy. We do something like this. Copy that, add to NavMesh, and we just bind it to the underscore add to NavMesh function. Remove from NavMesh like that. And yeah, this is what like an AngelScript function prototype looks like. So it looks kind of like C++ or C or something. Minigame logic component is not what we want. We actually want to register this with its proper name. This could essentially be anything. It could be like a query or whatever, as long as it's unique. Just so that this component can conceptually exist in the AngelScript world. We don't typically really refer to the component by its type name, because we're kind of just going like self.this or self.that. But it needs to be unique, so it kind of makes sense to just use the same name as you have here. All right. Then, what's next? Let's get the NavMesh runtime Zig. Where did I put it? There it is. Put it off to the side here. Right. So we have these three. We have these three obstacles. Maybe we'll want to have the type be an exposed property as well, so we can set it there nicely in the editor. And that should be an enum somewhere. Yes. That's an I32. I wonder if I32s are actually supported in the exposed properties. Well, we can hard code it for now and change it later if this doesn't work. It might work. I think on C++ I have like a limitation that my enums need to be unsigned int32s if they are to appear in the editor, but might not be a requirement. Oh, I'm actually messed around with something like that. Okay. So, NavMesh obstacle type. Let's just add this as a member. Obstacle type. This would be like a means dot. Was it AI? No, it's NavMesh probably. It's not means actually. It's basis. NavMesh runtime. Obstacle type, and that can be probably large, makes sense. Yeah. Yeah, let's keep it as large for now, and we can expose that later. And then we have a few different NavMeshes, and the question is, I haven't really used more than one NavMesh in any of the games with this engine so far. But I've come to realize that I need more of them. Luckily, I've had this for a while. This used to be called Permutation 1, 2, 3, 4. I've sort of renamed them to Auxiliary 1, 2, 3, 4. So you have like the main NavMesh, and then you might have some like secondary ones. The reason I don't want to call them permutations is that NavMesh permutations are typically, at least in my experience, they're sort of a version of the main NavMesh. So you have a single NavMesh, you apply a permutation to it, and that maybe like changes that the main gate could be one such permutation that suddenly you can actually drive there. These are sort of separate NavMeshes altogether. You can have a main one, and then you can have a secondary, a third, fourth, etc. And then the permutations are essentially like the obstacles that we are adding and removing and moving around. But still, we might have any number of them, or up to 5 currently. And so basically, we need to keep track here in the obstacle component which NavMeshes we have applied the obstacle to. And I think like by default you should probably apply them to all NavMeshes that there are in the level currently. That kind of makes sense, doesn't it? And remind me, because I can't remember exactly, but I need to basically get the count, the enum count. Enums, values. This is probably how I've done it. Yeah, you can get a len from there. Let's search for that. Material effects. Yeah. This looks like at least one way to get that. So let's have that be the thing. Actually, should we can even do like a pub const here. Max nav mesh count can be quite simply nav mesh id len. Right. And that should be fine. So this is like 5 basically. So we have obstacle IDs, and this would be basis navmesh runtime, max navmesh count, basis navmesh runtime, navmesh obstacle ID, that one. And do we need to initialize this somehow? Actually, I did initialize it like this. Yeah, this is weird. It's a weird syntax, but it's fine. Let's use the same thing here. Maybe I actually want to shorten some of these guys. Let's shorten some of them. Basically take that part away. So in max navmesh count, we have obstacle type, we have navmesh ID. I love it how in Zig it's so easy to just like redefine things all over the place. While still keeping it remarkably easy to see what like the original type was. These kinds of things can quite quickly become super messy, but yeah, in my experience that's not really the case. Right, so we have a bunch of NavMesh IDs. We kind of infer how many. We want to initialize them to the invalid value. right? So something like this, NavMesh. I hope this will work. We'll see soon enough. So take that away. So basically we have a list of IDs that all get initialized with this value. To be able to actually see if this compiles or not, I will have to register this component. So let's do that. Call it something like S for the time being. And now this is nav, scripted NavMesh component. And we replace that. And then we push it to the list. Now we can build. See what's going on. No field named, oh right, current diamond, blah blah. That's true. What was this actually? Game state. Oh, it's a propagator value. Okay. All right, so that builds nice. That's nice. Okay, so in on object created, I think this is probably the place where we would want to create the obstacles. And basically we need to ask the NavMesh runtime, hey, what NavMeshes are there in the level? And then just add the obstacle there for each of them. And to add the obstacle, we need to know the position, and we can get the position if we just have a transform the object, so that shouldn't be a problem. So that's like initial position here. Velocity is, that will be 0. Type we have, but we need the radius, so we need to expose a radius float member here. So let's do that. Radius F32. That should be easy to do. Property. Parent type is self. Type is float32. Radius default value. What should we use there? Like 5 maybe. No options. That should do it. Oh, we probably need to actually initialize this to something. Yeah, this is a little silly because like this default value here is the default value that will be applied when this component is created, unless we've actually set it to something else in the editor. But Zig doesn't know that, and Zig can't really know that. Well, I guess in theory it would be possible to figure out that is going to happen, but still Zig will complain if we don't initialize it here as well. So we put that to 0 instead, so that if we change this to something else like 7, then we have like 5 and 7, and then it's like confusing, like, oh, which one is the correct one? That is clearly just like a way to initialize it to something, and then we set the proper value here. Okay. Right. So let's get cracking on this adding to the thing. We should have the self context transform get position. Right, that's the position. So world position. And then we have linear velocity is quite simply vec. It's basis math vec 3 0. Yes. Now it can be just position. Something like that. And then we need to iterate over the of the IDs. So again, we need to somehow... let's have a think. Let's have a think. This gives us values. So const e returns a set of all named values in the given enum. Okay. So these are like just linearly increasing. We could just iterate from 0 to 4, but maybe it's nicer to do it this way. So we'll do for stud enums values of NavMesh ID. We don't actually have a NavMesh ID here. We can do that as well. Shorten it. So this would be basis NavMesh runtime, NavMesh ID values, right? Oh, actually, it's this. Yeah. So ID. ID is NavMesh ID. Thank you, ZLS. So if basis NavMesh runtime has NavMesh with the ID, then that is when we want to actually register it, right? So we can do const index is index can be a usize, and we can do int from enum ID, get the index, and then we can do self dot obstacle IDs index equals basis NavMesh runtime add obstacle. That would be ID. Radius would be self.radius, self.obstacle type. That would be position, and that would be initial velocity. That's called just linear velocity. Let's add a comma there to format vertically. And there we go. That should do it. That quite simply should do it. And then in on destroy, let's have a think here. So now we're just adding it there with no regards for if it should be added or not. So we can add here a boolean. Let's call it something like add at creation. And it can be false maybe. Right. Just basically whether or not we want to have them be automatically added without us having to do anything. So bool add at creation default value would be I'm a little annoyed at this. Whatever they're called, these helper strings here, because it makes the caret sort of jump around a little bit. But right, add at creation is false. We can set it to true if it is true. If actually we can just do everything here. If self add at creation, then we add them. And I think I now see that we'll want to actually extract that into its own function. Add to NavMesh. That is basically exactly what we want. So let's just yoink that out of there and put it there instead, and then just call self.add to NavMesh. Right. And now we have the script API hooked up already. That should be fine. And then basically we do the opposite thing here. So we don't want to check has NavMesh necessarily. Instead, what we want to do is want to get the index, and if self obstacle IDs for the index isn't invalid, then quite simply we want to do basis navmesh runtime remove obstacle ID, and we basically have that one, the ID, and then we set it to the invalid obstacle ID. Does that make sense? I think it probably does. And then in destroy we also want to quite simply call that. And if none of them are actually added, then this if just skips the removal, so that should be fine. Yeah. Yeah, that looks good. And maybe we can just, as a small helper, add some debug output here to make sure that we can see that it takes place if we need to do that. And for that I'm going to get the game object. So self context get game object, and then we can do basis printf. I'll add the format string there in a second. So we'll want to probably get like game object get name, and then we'll want to have like tag name for the ID. So added navmesh obstacle to navmesh something like that. Does that make sense? And then new line. Let's not forget. What? Int from enum. Right. So because that it is an I32, yeah, it actually just give it. Let's try it like this. Let's try just like use an I32 there. Expected type. Yeah, this is annoying. That's annoying, is what it is. And of course, the reason this guy is this guy is like an I32 is because that is what it is on C++. So it technically wouldn't need to be that, but that is what it is currently. But okay. So let's do like an int cast here. That should work. So do an int cast and then an int from enum, or the other way around, really. Yeah, that should be fine, and it is good. And we can do the same thing here. So removed navmesh obstacle from navmesh. Yeah. Okay. Is that everything? Might just be everything. Yeah. At least I don't see anything obviously wrong with this. So, the only thing we need to do now is add a game object type with this component. And then we can start playing around with it. So to blueprint, and we have AI blueprints. Racetrack, yeah, this was like a really, really old thing that I tried. Let's do AI scripted NavMesh obstacle. It has a transform. We don't need it on the client. We do need it in the level editor, so that's fine. And then another component. This is the string that we want. Obstacle. It will complain that the type is not registered, and that's fine. We don't need it to be. Level editor, sure. Yeah, that's good. That should be it, really. Okay, so if we filter by NavMesh, we have scripted NavMesh obstacle here. And basically what we can do now is we can add it just to the base layer to test. And we can add it, where should we add it? Let's add it like around one of these boxes, just to see what it looks like, if it works, etc. So here we can, we can see we have the radius here, we have added creation, and we will turn that on. Let's make that a bit larger, let's make it 10, and I can just remove those. So let's do like dev add large. Oh, and it needs to be void. So this dev annotation here means that I can actually call this from the development menu on the top of the screen. And here we can do self add to NavMesh. And remove large. Remove from NavMesh. That should be fine. Right, so we have the large one. That's the large one, and then we can duplicate. Oh, up, not like that, but like that. And we'll move it off to the side, move it onto that one. Let's make this smaller, so this would be 5. It's not actually added at creation time. We'll just call this add small. Like so. All right, let's try this. See what happens. And we'll want to fly over there. Right, so now if I enable drawing of NavMesh, the large one should be there already, right? Yay, look at that. And if I remove it, remove large, it goes away. Add small, and we get the smaller one. Yeah, these things here are actually not, they're not like edges of the NavMesh. You can see that there's no edge here. You can see an ever so slight darker edge to this. This just means that it's intersecting with the terrain, which is a little stupid, but that is what that is. It seems to do the same thing over here. Remove small, kind of changes it a little bit, but that's just because now we can tessellate this as basically like two triangles, and if we add it back in, it needs to do a whole lot more. You can actually see the edges here. Apoc, hey, welcome back. If you've seen more more videos. And I'm happy if my videos have inspired people to try out SIG. That's great. Let me know how it works out if you do end up jamming with it. I bet it's a pretty nice jamming language. I haven't actually done that myself. But that sounds awesome. Cool. Okay, so this looks like it's working. Add large, add small. We can have them both there at the same time. Another thing that we should probably try out is adding a second NavMesh. So we have NavMesh 1 here, which covers basically the entire level. If we draw this, we can see that it covers not really the entire level, but even some places here where it arguably shouldn't, like up here. And so this is the main one. But let's add a second one here. So test this out. So we have NavMesh 2. And it finds some old crap that I have lying around on the disk. But we'll build it with these bounds here. And we'll see what happens. Right. So we can see that it doesn't actually exactly match the bounds, and that's not really the point of it. Turn off this drawing of that NavMesh. Yeah, it basically adds the tiles that intersect with these bounds. So you can see the tile intersecting the bounds here, but then it kind of goes outside of it a little bit. That's fine. And now we should basically be able to see those obstacles on both of them. I'm gonna lift up this NavMesh drawing a little bit. So draw Y offset. You can see that we can actually move this upwards in the air. You can move it actually quite a lot if you want to. It only affects the drawing, and that means that you typically get rid of those intersections there. It can be kind of annoying. Sure, we can save. I'm gonna probably have to revert all of this anyway. So if we go here, and now it should draw both of them, and it does. That looks good. That does look a little buggy though. Doesn't look like it's actually going to both of them, but let's see. Let's have a look. Remove large. Add large. So does it actually cut into the one below? It looks to me like it doesn't. And that's not good. Add small. Remove large. Yeah, like it's clearly cutting into the top one, right? But it doesn't look to me like it's actually cutting into the bottom one at all. We should be able to see those outputs here, though. From NavMesh main. Oh, so it's okay. It's actually adding and removing from the main one, not the top one. Okay. Huh. Why not? Why not? Right, so we have the remove large, remove small. Yeah, it's only adding it to the main one. Okay. Yeah, that's not good. So why is that? try to figure that out. I'm gonna unload that so we can make some changes to the code. Oh, and I know why that is. And it's actually a data problem. I don't want that. It's actually a data problem. Because the thing is, and this is by design, but I wonder if it's a good design because it constantly confuses me. But this is how it works, and this is probably how it's gonna work. We have NavMesh 1, that's the main one. Then we have those two obstacles, and then we have NavMesh 2. So by the time this is the creation order essentially when this base layer is loaded. So we quite simply just need to move the NavMesh above these obstacles, and that should fix it. I do think it's a pretty good design, but I keep sort of tripping up on that even years later, so I don't know. I need to be more careful, but okay. So again, we should have the big one there. It is not doing it though. Quite simply. Remove large. Add large. Yeah, it's not actually... Oh! And there's another data issue. Yeah, I'm really showing my best side here, aren't I? So runtime, we need to register this with aux, auxiliary 1. Yeah, there was a warning there in the lower right corner of the screen that, hey, you actually already have a main NavMesh. Can't register another main NavMesh. Now we should see, yeah, main and auxiliary 1. Good. Alright. That looks better. There we go. Alright. Yeah. And you can see that the tessellation of those, they don't quite overlap, but that's fine, because that like overall NavMesh shape is different, so everything will be different. Remove large, add small, add large. Yeah. Works. It works. And you know what that means, don't you? That means that, well, first of all, it means that I will revert this level changes that we did, and then we'll fix up that gate. Yeah. Wants to throw all those windows on the main one. Right. There we go. So let's reload this guy. So basically what we want to do is, when this gate has reached the halfway point, about here, we want to remove the obstacle. And we want the obstacles to be added at creation, or whatever we call that thing. Let's see. Set playback speeds. We play an animation, path animation, right? Right. I wonder, can I actually create timers here? It's it's of course easier if I just quite simply add and remove these things when we start playing this. And so that is like the minimum viable product here. But let's think about this. Can we actually time it somehow? Yeah, what is annoying currently with these SIG components is that you can't create script timers, right? Control script. This is a timer though. Yeah, okay. The reason this has a timer is because this script component is actually a C++ component where timers are implemented. I should really implement them in SIG as well, but yeah. Yeah. It is what it is. So many things to do. Okay. Let's just add the thing here. So we have two doors. Under sliding door 1, we will add one of these obstacles, and we'll copy the transform, except I think we will want to perhaps move it over slightly. Something like that. And we'll just call this NavMesh obstacle. It is added at creation time. 5 is probably too small. Let's make it 8. And we can see what that looks like. Oh, before we do this, actually, we'll want to actually make sure that we can have a quick look here now that I have it there, but I want to make sure that the gate itself doesn't block the NavMesh. So this looks a little small. I should probably add some visualization to this in the editor, right? But let's make it 10, and let's make a quick detour here into the blueprint land, and let's see what is the blueprint for those refinery level specific, maybe. No. Sliding door, that looks good. Yep, that is the thing. So we'll quite simply just want to mark it as not blocking the NavMesh. That's fine. So basically what we could do here, if we wanted to, is that we could add one of those obstacle components to this component itself. This already has a scripted component though, so maybe it's easier to do it like this. No longer blocking the NavMesh, and we'll need to reload this to make sure that we can rebake the NavMesh without those gates blocking. Hey Tutu, welcome back. Right, so we go here, and now we want to rebake this. This should actually open up, right? Let's make sure that happens. So this is the main one. We rebuild it. This will take a few seconds to do. All right, and we're done. And we can see that we now opened up this path. Those gates no longer block it. We can just move them out of the way, and we can see that yes, it is actually unblocked now. And so now it's really quite important that we get these these obstacles there to actually block the path for now. Yeah, the seagulls have mostly moved on this time of the year. They've had their offspring and they move on to other places. That is true. Cool. So basically what we want to be able to send a message to this guy. Hey, remove yourself. So we can do if message equals remove. And quite simply call remove from NavMesh. So once these gates have opened, they really no longer close. But I do have the development commands there to add and remove them. So maybe we'll have an add here as well, like that. I think so. And then we'll duplicate this guy, move them over there. Oh, come on. Like so. And we will need to move this over here. And we'll need to make sure that they actually block the thing now. So now we have them added at creation time. Let's just run the game and see if it actually blocks the entrance, because that is what we want and what we need. Right, so it's a little too small, but maybe we can just move them a bit closer to each other. I think that should probably fix it. So I actually could, in theory, support boxes and not just the circles or cylinders, as they are actually. I used Recast and Detour, the open source NavMesh framework for this. And Recast actually supports boxes, box obstacles. So that should be fine. But I think we'll go with this for now. That looks good. So now we have it blocked. And if we need to make it even more precise, we can always add more of these. Have sort of a bunch of these smaller obstacles there blocking that. But yeah, that'll be fine for now. And we can set add and remove to those. So control script. Yeah, let's just do it like this for now. Self send message. So receiver and message. So this will be level objects, lift station, main gate, sliding door 1, NavMesh obstacle, remove. I'll just remove it immediately when we're opening it up, and then adding back when we're closing, because then we have it all nicely in this one place rather than sprinkling it around, tying it to timers and all of that. Yeah, add. Okay, I think that should be it really. So, NavMesh, the path is blocked quite clearly. And if we open the gate, it is no longer blocked. Look at that. And if we close it again, it becomes blocked again. That's nice. I'm a little annoyed at this shape here, that it cuts out all of this, but maybe it'll be fine. All right. Sorry about that. I got a phone call. Right. What happened to my game? Ah, nothing happened. I just don't have mouse input. Cool. Okay. Yeah, I was saying that I'm a little annoyed at the shape. Would be nicer if we didn't have to use two of these. So maybe what we'll do is this. I will actually call that 1. I'll call that number 2. I'll move all of them under this one door. So door number 1 will get to control Actually, why am I making it so difficult? I don't need to split it up like that at all, actually. I'll quite simply call that number 1, and I'll call this number 1. And then I'll make that probably like 6. Move it off to the side a little bit. And the second one there. And then do the same for this. So number 1 and number 2. So 1, 1. Yeah. Let's try that. Yeah, that looks better. Except we need to move those a little closer still in the middle. That's fine. So it's number 2. Right. I should make a command or console toggle to make that visualization there easier to turn on again. Yeah, something like that. I think I can still afford to move these center ones a bit closer together. So I've had a feature on my backlog for a while now. Again, it's one of these things that are sort of handled kind of nicely in C++, but not really all that nicely in SIG. And it's a way to actually make editor-only visualizations a bit easier to add. Well, they're not tricky to add in SIG, but most of the time you'll add like an update or tick function to a component just to be able to have it draw itself in the editor. So, now for example, now when I'm moving these guys, I have to kind of tweak these positions because I don't see what it looks like here in the editor, only when they're actually added to the NavMesh. In C++, there's something called draw editor, which is like an editor-only callback that you can handle that in, which means that you can add all kinds of visualizations and other editor logic without actually having to add an update or tick function to the component type, which is good for performance. I should really add that to SIG as well. That would be easier than to add visualizations to these things. Oh, I closed it. Yeah, open. I think we broke the script somehow, right? Yeah. What? Add and remove. Oh yes, you're very much a part of everything I do. Every mistake I make, we're making as a group. I'm sure of it. This is confusing though. Debug info. Remove. I probably just messed around with it a little too much. Open main gate. Remove. Okay, now it works. I don't know. Did I not rebuild it earlier or something? It's possible. Anyway, now we should, of course, be able to control this. I'll give those orders in a much nicer way. So maybe we can try a little scenario here. I just want to make sure that. So if we open the gate, those go away. That's fine. And if we close it again, they come back. I'm a bit confused by that earlier problem. Yeah. Okay. Right. So what I need to do then is actually export this level. And I think we can unload it. I'll run it from here and I'll actually load into the campaign so that we get our trusty AI companion to play around with. And this debug output is going to be interesting to keep an eye on. Right, so movement results success. Cool. Yeah, come here, move here. First of all. So like one of the most obvious ways to get into the base is just to lift the scout over the wall, right? It's not perhaps the most interesting way to get into the base, but it's one of the most obvious ways to get into the base. Let's hope the mother vehicle can make it here so that we can actually try that out. So basically, switch to the mother, and the scout is rolling away. Don't go, no. Stay. Yeah, I switched the avatar selection or the avatar role, basically switching from like driver controls to crane controls and all of that. Switch it from the right bumper to the left bumper now because I needed to make a button available for the radio menu, and now I keep clicking the old one, activating the radio menu all the time. All right, so let's see if I lower this down like that. Right, we get some nice dialogue here. Again, I don't want that. Thank you very much. I want to switch to that. This is actually kind of interesting. Now I would actually want the AI to sort of maybe retract that cable, but I can't actually give that kind of command to the AI. Oh well. Anyway, now if I am like, hey, mother vehicle, please move here, it goes, I can't find the path. And so that's not nice. But now if we open the gate, open main gate. And now I tell it, look at that. Now it's like, okay, I'm gonna come there. And then it gets stuck probably somewhere, yeah. You're so bad at driving. Yeah, I need to work on the reverse turns and all of that quite soon actually to fix all of this. But I have some pretty good code already to just snitch from project slide for handling all of that, so Not sure if it will be enough, but yeah, I need to just basically take that stuff, port it over to Zig, and put it in here and see how far that gets us. Anyway, the NavMesh stuff clearly was working, so that's good. It's basically what I wanted to get out of this thing. And now, of course, if we do this, what happens now if I just out of interest just turn this thing, because again they don't want to do reverse turns currently. So let's help it out a little bit by turning it, aligning it properly with the direction, and then we'll switch back to this guy. And now you're like, okay, well, why don't you move here? And you can see that they start moving. That's fine. And now close the gate. Right. What is the mother vehicle going to do now? They they gave up on life apparently. Or are they actually? No, yeah, they're... What the hell? Where are you going? That's interesting. Well, now we can debug the AI brain again, and we can see, okay, blah, 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 blah. Right, so it does have a path, 41 vertices. Yeah. Like, it's clearly not doing anything sensible. I wonder if it somehow broke, because like now that path is no longer actually valid. It's possible. It did look a little bit though like it would have turned when it came up here, so I wonder if it had like a separate plan. Of course, I can't unfortunately draw this path that it wants to take currently. I need to do that as well, but that's not currently possible. Actually, maybe we can make it possible. Let's have a quick look here. AI driving component. Debug draw. Right. So this sits behind a Boolean flag. Yeah. Yeah, that's interesting. Because what we could essentially do is just yoink this out of the whole update function. Also means that we could get rid of this completely. And then in this new debugger imgui thingy that I added, where is it? It's right here. Draw debug imgui. Yeah. Maybe take that away, quite simply. Debug drawing, the drive line should actually show us the path that it's going to take. That should be interesting. So I haven't actually showed how this brain debugging works. It is again one of these things that are just like, it's so hacky. I'm a little afraid of actually showing it to anyone. Let's see, debug AI brain. Look at that. Now we can see the path, and that is going to take. Those numbers over there are speed scores, if I remember correctly. So the driveline gives like a score to each of the points as the vehicle is driving through the world. So if you have a tight corner, it should, at least in theory, give it a lower score. Let's see if that is the case. If I move up here to the gate, and then I ask the motor vehicle to come here. Yeah, you can see here that when it is approaching the corner, the score is lowered from 1 to 0.0. And then as the path is again more straight, it gets the full score again. It's kind of interesting that they get exactly 0.7 all of those, but I don't remember exactly how I calculate those. But yeah, that's nice. I think that might be a pretty good way actually to like hack in the debug drawing into that brain debugging thing. Okay, so that's good. Let's open the gate. Open main gate. And we can actually switch to this guy. Let's do the same thing again. Again, reversing here to make it as easy as possible for the AI to actually get the ball rolling. And so now, if we switch back to the Scout, I actually look at it from this perspective, right? So we'll start by asking the mother to come to the Scout, and it should give us a nice, yeah, you can see the path kind of makes sense there. But then we close the main gate. Yeah, look at that. Now it wants to take a completely different route. And what is the route it wants to take? Ah, yeah. See, this is something that happened because of our changes today. The reason it gets stuck there is just because it's kind of bad at driving. But of course, this gate no longer blocks the NavMesh either. So there's nothing wrong with the AI system other than it being kind of bad at driving still. But this gate should be closed, so you should just go like, oh no, I failed. My NavMesh query failed. So how do we do that? How do we close that? I don't want to add an obstacle there. That's kind of annoying or unnecessary. That's kind of unnecessary because I don't think this gate will actually ever open. At least I haven't scripted it to open ever. So what do we do? It would be pretty handy to have like a NavMesh obstacle object here that you could sort of put in the like an editor only thing that would just quite simply mask out areas that the NavMesh will never actually will never actually be generated in. But what we can do is we can add a new layer, and we'll call this NavMesh blockers. And here we just do a primitive geometry object. We make sure that it is set as a NavMesh blocker. And make it something like 10, 5, 1. $30, something like that. Maybe we can make it something like yellow. It kind of stand out a bit more. Right. So now if we regenerate the nav mesh, this should mask out the area. But since the layer where that object sits is not set to auto load, that object won't show up in the game. That looks better. Maybe I can be a bit more careful with the size of that object. 26, 25, 22, right, 24. That's probably fine. Actually, we can just copy the transform. Yeah. Yep, that'll be better. So now if we do this whole thing again, the mother vehicle should probably report some kind of path finding failure when we actually close the gate. Oh, actually, I can't run it like this. Yeah, I need to export it. I'll run it from here. And then, of course, there's the thing where where this mother vehicle should have their completely own nav mesh, which is like a whole different body of work. Let's make sure this works. Right, so move here, and then we can go have a look here at this gate. And yeah, now it's blocked off. As it should. Good. We have the mother vehicle approaching. Hello to you. All right, and open main gate. Looks good as well. Yeah, I have a feeling that we'll want to block off, sort of nav mesh wise, we'll want to block off that whole section of the level of this base, so the mother vehicle doesn't try to drive there at all. It's a little risky to do that though, because the player might drive there, essentially drive off where the mother vehicle should never be, and then leave the mother vehicle there. And then what happens if you tell the mother vehicle sort of to drive to you, and then it's kind of off its own nav mesh. So it's it can be a little risky actually to do that. We'll see. I'll figure something out. Okay, one more thing, or one more try. So come here, and now close main gate. Yeah, and now we can see that. Okay, path not found. It quite simply realizes that I can't actually go there. If we ask it again, it will tell us that no path is found. And if we open the main gate and ask it, then it will figure it out. Hey, that's cool. And now I got stuck on a box. Oh no, help me off this box. Can I get off it? Can I get off it? Yeah, I can. Can't I? Yes. Nice. Okay, excellent. Well, this kind of works. There it is. This kind of works how I expected and or wanted it to. So that's good. What is next on my to-do list then? Right, so the next thing that I would need to do is actually tell the brain component, so the sort of entry point, the master AI component, which nav mesh they are to use when moving around. And then I need to add that other nav mesh there and make the mother vehicle use that. There's a little bit of work involved in that though, because I need to essentially limit the areas of the level where I want that nav mesh to be generated. You can do it currently with like a bounding sphere or a bounding box, like we did previously, but that's just an axis aligned bounding box, and so I don't think that we will actually be able to fully represent the area where we want the thing to actually be generated with just a bounding box. We actually have a bounding box for the main one as well, which you can see here, which I'm using to sort of limit the area a little bit, so that we don't get nav mesh generated up here, for example. But for the mother vehicle, we'll probably want to have some of these areas sort of completely blocked off, while others need to be accessible. So yeah, we'll see how that works out. Yeah, and then we have the thing where we're currently in this new component that we created here. We just go through all of the all of the created nav meshes, basically this if here. So we don't necessarily want the obstacles to appear on all of the nav meshes. That can be actually super handy if you want certain vehicles to be able to drive somewhere and not others. You only close off some of these nav meshes while leaving others open. So let's have like a to-do comment here. Perhaps add the ability to select which nav meshes to add the obstacle to. And I think we can remove these at least for the time being. Yeah. Well, yeah, I think this is probably all we need to do for now. So, what's next then? This was actually surprisingly easy to do. I was kind of expecting it to be harder than this. Do we have any other gates here that need to be closed off? I don't think we do. Yeah, that looks kind of annoying currently. And we have this, we can actually hide that thing. So now it's hidden. Hidden in the editor. Yeah, hidden is probably alright. Okay. Wonder if I should keep going with the radio system a little bit. To be honest, I hadn't spec'd anything out for it currently, but it might be kind of interesting to have it report something about how these things actually are carried out. It's one of the next things that I want to actually have working here. So so let's see what we have. When we issue an order over the comm radio, we actually, let's see, where's the entry point? Send radio messages here, right? And what is this actually? On message sent, right? So we have component. I don't remember how this works anymore, even though it was just like a couple of weeks ago that we did this. So we currently only have the move here command working. We can add more of those commands. Move here, follow me, and stay put are the three that we have that the UI can show, but we actually I don't have any AI code for those other ones. And basically I think this place here is kind of like where we determine if the thing succeeds or not, right? So if we play the game, And now, of course, I don't probably have any peeps to. Yeah, no contacts within range. Well, what about those test vehicles? I still don't have any contacts within range. But we can actually remedy that quite easily. Test vehicles. Let's add. There's a scout somewhere. Scout inside of the shed. We'll just turn it the other way so that it doesn't have any problems actually getting out of the thing. And then we'll quite simply enable its comm radio, right? Radio enabled. Scout in shed. Now we should be able to have the scout in the shed do things. Alright, so no contacts within range. Load test vehicles. And now we have still no contacts. What? Why are you not there? I think that was the only thing we needed to do. Radio enabled. Interesting. Did we find a bug? Com radio component. This should be, let's see, register contact. Oh, is the problem actually that that we need like our own radio to be enabled as well? Oh, what is this? I have the game running apparently somehow. Let's see. Yeah, I bet the problem is that we need our own radio to be on as well. That's kind of arguably perhaps not necessary, but makes sense, I guess, to some extent. What if we do something like this, where there's the spawn point. This is where we spawn. So we'll add test vehicles, scout. Can add a new scout here, somewhere there. Set the radio on, and we'll call this like scout. In slope or on slope. I don't know. It's a sloping terrain here. So test vehicles. There's the scout on the slope. We don't have any contacts here, but if we switch to this guy, yeah, now we have scout in shed as a contact. So that's perhaps a little unnecessary to have like the requirement there that we need to have our own radio on. But I guess in some sense it is fine. So, yeah, move here. Can you move here? Yes, you can. Looks good. Right, so basically what I think should happen here is that when you open the radio, immediately when you select one of these guys here, like Scouting Shed, for example, this is where like one of the characters could say something like, "Yes, what's up?" Because you've essentially sort of opened the radio, a radio line of communication to them, and then if you go like move here, if they can do that, then they will say something like, "Yeah, on my way," or whatever. And if they can't, then they need to tell you that I can't move there. I don't know how to get there, right? So there's like a sort of a greeting, like, yes, what is it? And then if you go back, they could say like, you know, over and out or whatever. Add a little bit of radio radio flair to the thing. That could be fun. Oh, what's going on here? Okay, not sure what's happening. Oh, I actually, yeah, okay. I wasn't running it in a debugger, so it just completely freaked out when I pressed debug there. Yeah, probably some drive line issue. Basically, we're trying to normalize a zero length vector. We can't do that. But yes. So anyway, it's sort of like it depends a little bit on the command, when and how it can determine if it's sort of a success or not. Like we can always say hello when you open that menu, but then when you go move here, for the AI to be able to like select whether or not it should go like on my way or I can't get there, it needs to figure out at least if there's a path on the NavMesh to the place. Where is the guy, by the way? Oh, they immediately got drove into the wall. They're so stupid. Alright, well they selected a somewhat okay path, but then they just drove into the wall. Alright. And you can see it's trying to actually it does continuously make new queries. That's why these guys are sort of moving around a little bit. We can always just remove the shed completely, and there we go. There's your path. So that's okay. I guess this place looks interesting without this building here. But yeah, so how do we actually determine whether or not this radio command is possible? Let's look at the code a little bit. So we have the com radio component is the thing that handles this on message sent move here. Right, so some of these are clearly sort of just for debugging, you know, like if you can't find a brain component in the object it says cannot move. I have no brain. Well, yeah, that should really never happen to the end user. Or sender has no transform is also sort of a debug message. But then like can't find target position. This is kind of I guess that could happen in some very specific circumstances. And this is where this is kind of like the first point of failure that we want to report to the end user, right? First point of end user facing failure here, maybe, not sure. But then we have this, we have the AI brain, so we clear the layer, we clear all the other things that it was doing, if it was doing something. And then we do this, we append a move to position action to the scheduler, and we need to basically figure out if this immediately fails. So that's interesting. And I wonder how we want to actually do that. Like when the action scheduler appends an action there, one thing that we could do is have sort of the action scheduler, if there is an action in the scheduler that fails, we would have a callback that we can set. And this component could set the callback on the action scheduler. If an action fails, we call a callback. And we somehow give it an idea, an ID or something for this action, which we would already get here when we append this thing, right? So basically what we do here is we create a new action, we create it on the heap using the allocator, create T, we initialize it, and then we push it to the queue, and we return the action. Now I wonder if the action already has some kind of ID. So we have an interface that all the actions implement. We have get type, we have get state, we have a get debug name, but we don't actually have an ID. And that could be very, very interesting actually to get out here. So then what we could do here when we move this, move to position, this just returns void, or it's like an error returning void. We could return the ID here, and using that callback, we could sort of make this com radio component aware of if something in this brain component's action scheduler fails, we want to get notified of it. And then if we store this ID that we get out of the move to position function here, if that is the action that fails, then we know that, okay, whatever we asked, whatever this com radio component asked this agent to do failed, so we want to essentially let the end user know. Does that make sense? I think it probably makes sense. And this is probably pretty good to have in somewhat early, because we don't have that many actions yet. We have moved to object, we have moved to position, and we have like an explicit disable AI action. And those are the actions that we have currently. Yeah. So let's look at the scheduler then. And I think the scheduler is probably in the, is it in the game helper library, I think? Oh, that's the timeline stuff. Okay, so then it's probably in means itself. AI actions. Action scheduler, here we go. Right, so we do an update. And we're basically switching on the current actions state. The task has ended. Get rid of it and start the next one if available. So here, if this was failed or interrupted, then we could call that callback. Or in actuality, what we could do is we could just have the callback basically be fired even if it succeeded. Maybe you would be interested in knowing if it succeeds as well. That could be kind of interesting as well, yeah. So essentially the callback would be sort of like the task ended, just like this comment says. And then as a parameter you would get this state. What was the state of it when it ended? Okay. And then we need to figure out, okay, so how do we, I think that is not super tricky. How do we actually send that information to the com radio component? This guy here. So this guy gets a pointer to an AI brain component over here. Just looks for it in the parent object. And it is of course an optional one, so it's possible that it doesn't have one, but that's very unlikely. The brain AI component, though, this guy doesn't really have any, there's no mentions of radio here. But what we could do, because this thing is kind of intertwined, like the com radio component doesn't really work without a brain component. What we could do is quite simply have the brain AI component also get a pointer to this com radio component. And then whenever an event happens, whenever an action ends in the scheduler, if the brain AI knows of a com radio component, it just notifies the com radio component, hey, this thing actually ended, and maybe you want to tell the player about that. That could work. That could work, right? Okay, so now we have it this far. So what would then the com radio component do? I think it would probably play essentially mission dialogue. So basically, we want to like play a line of dialogue that has subtitles and maybe some audio. So the com radio logic runs on the server and just propagates to the client. So we have things like this. Or things like this. I basically just want to show one of these guys, depending on the outcome of the radio message. So how do we do that then? Com radio component probably only runs on the server, or does it? I think it probably only runs on the server, yeah. And the reason I think that is that it just gets a brain component here. This definitely runs on the server, but doesn't only run on the server. I think it does. There's actually very little client-side stuff involved with this AI at all. It's almost completely server-side. Okay, and that's fine. What about actually showing those dialogues, though? How does that work? So that stuff typically comes from Nemo, and technically it's sort of part of a mission. So it's like a mission dialogue essentially. How does that work? Let's see. Mission unlock. Mission. All right. Mission dialogue. So it just sends a message. Yeah. Here we have it. This probably comes from the C++ side. So mission dialogue. This contains all the information about the dialogue line. We don't really use the mission path for anything currently. But we have the text, localized text, audio, character path, hash, and duration, and then we just push it to the HUD. So basically, we need to be able to send a message like this, but we need to be able to send it on the client. And of course, this com radio component thingy is only running on the server currently. However, what we could do is have the com radio component run on both the client and the server. The brain would still only run on the server. If we go here to vehicle blueprints, we can look at Scout. I think this is probably like the last one that we have. Okay, so com radio component actually does run on the client currently. We just don't really do anything with it there. But we do run this on the client. And so when this fires, we probably want to notify the client somehow that okay, this is now going on. We've issued a move here command on the server, and we can do that with a propagated value. And then the client side of this can send that message to the HUD to show the thing. Yeah. There's some stuff to figure out here. Yeah, I hadn't really spec'd this out at all, really, because I kind of figured the NavMesh stuff would take up all of this stream. But I would like to spec this out a little bit more before I actually start working on it. So I think we probably won't get into actually implementing this in this stream. I'll probably leave it for the next one. Because I need to sort of decide if that is how I want this thing to work in the end. There are some ramifications if I do it wrong. But yeah, this was good. I got the NavMesh stuff solved. Seems to be working quite well. And so that is nice. Technically, I should have, I think, all the tech now in place to implement the mission fully. Might be one or two things that I haven't thought about, and I still need to add. But most of the stuff was there. The radio system was a big one, but of course it didn't really fully work until I could block off parts of the NavMesh. And now I can do that. So I should probably have everything I need now to script that finally. And when I have that, then you can essentially play through the demo from beginning to end. Of course, there's still a large chunk of this level that isn't decorated, but that's not really a prerequisite to be able to play through the thing. But that's that. Does anyone have any thoughts or questions or things you'd like me to cover in this stream today? Otherwise, I think I'm gonna probably end pretty soon. Maybe we'll do a little bit of level design in an upcoming stream. I haven't really done any of that in a while. That's pretty nice to do on stream. It's kind of laid back and not necessarily easy, but it's sort of like the kind of work that I can do while just talking about things quite easily. So I probably would just pick a part of this level and start decorating it relatively soon. So stay tuned if you're into that kind of stuff. Anyway, I think I'm pretty much done for this stream. Thank you to everyone who showed up. Again, a stream that was successful in the sense that I got the thing working I hoped to get working. If you like this kind of stuff, then be sure to subscribe. If you like the stream, then be sure to like the stream. Click the bell icons and everything to get notified of upcoming streams. And have a good day.